Use a hyperbolic substitution in calculus to work out this integral. We know we've got arc cosh in the answer. Well, the formula book is your friend here. You should already have dabbled with trig substitutions in A-level maths. So if you're ever dealing with this situation, you would do a substitution x equals a tan u. Normally when you first see it, there's just a 1 there, and then it's just x equals tan u. And also this one here, we let x equal a sine u. So they're your A-level maths ones. But now we delve into hyperbolic, but it's the same sort of approach. And what we can see, just looking at the formula book, is we've got the square root of x squared minus 1 on the bottom, and here it is. So what I'm going to be doing is letting x equal, in this case, just cosh u. That is going to be our hyperbolic substitution. So worth practicing these. And so if there was a 1 here, we would do that, and it would end up like things would end up cancelling, and you would get, of course, arc cosh as your answer. That's what makes this one a bit trickier because there's an x squared there, so we're going to be left with that after. We're going to have extra things. There's going to be extra things to do afterwards. So let's go for it. Let x equal cosh u. Then dx by du is going to be sine u. Then my integral is going to equal the integral of cosh squared u over the square root of cosh squared u minus 1. And then I'm going to be timesing by dx by du. This here is just sine u. Of course, you might be somebody who prefers to make dx the subject. I don't tend to do this, but you get the same thing if you then want to put it in to here. Right, now for the cancelling out part. I'm just gonna tidy it up first. So cosh squared u sine u over square root cosh squared u minus 1. Okay. Right, we need our trig identities, but hyperbolic ones. It's worth writing down like normal trig ones though. So sine squared plus cos squared is 1. And then when we deal with the hyperbolic, we invoke Osborne's rule. When you have a product of sine functions, you just end up making it negative. So we're going to get cosh squared minus sine squared that's equal to 1. And that means that sine hyperbolic squared or sine squared is going to be cosh squared u minus 1. And we can sub that in. So I can put in here sine hyperbolic squared u du. And then when I square root it, it's just going to become sine hyperbolic. They're going to cancel. So now I'm just doing the integral of cosh squared u with respect to u. Of course, I need to get it back in terms of x at the end. That's going to be probably the hardest bit. Now, this next bit is not a walk in the park, but it is something that you should have seen before, how to integrate cos squared, for example. And again, that is double angle formulae. So I'm going to write down my non-hyperbolic one. Cos 2a ends up being cos squared a minus sine squared a. But now bringing in Osborne's rule again, we're going to get cosh 2a is cosh squared a plus sine squared a. And I want it all in terms of cos. So now again, we can replace this sine squared by cosh squared u minus 1. And I'm going to get my double angle formula just in terms of cosh. Cosh squared a minus 1. Rearrange that. So cosh squared a is then going to be, I can add the 1 and then I can divide by 2. So a half plus a half cosh 2a. Okay, very similar approach to how we integrate cos squared a, but of course slightly different because the identities are different. So it's going to be a half times the integral. I might as well take the half out, I think. 1 plus cosh 2u du. Right, let's just keep track of what we're trying to get to. So then it will be a half multiplied by u plus a half sine hyperbolic 2u. Just reverse chain rule here. You can see when I differentiate it back, I will get back to that. And then I'm going to add on, normally I would add on c, but they're using a k here for whatever reason. So let's add that on. We're not going to need to modify it later on. Okay, now there's some good news. We've actually done the integral. Bad news is we still have to write it in this form here. Well, the first bit's not too bad. Remember, x is cos u, which means that u is going to be arc or cos x. And that's what I can put in here. So I've got this bit sorted. You can see it there and you can see the half there. So it's dealing with this sine hyperbolic 2u that's going to be a bit trickier. But again, trig identities. So remember, normal trig, sine 2a is identical to 2 sine a cos a. Now this time for hyperbolic, there's no Osborne's rule because it's not the product of two sine functions. So sine hyperbolic to a is the same sort of thing. So we are going to get a half, and then let's replace u by our cos x, and then sine hyperbolic 2u by 2 sine hyperbolic a cos a, so the 2 and the half cancel, and we've got ourselves sine hyperbolic u cos u plus k. Now this one here, remember, is x, because that was our substitution to begin with, so it's just getting sine hyperbolic u sorted. But we've already talked about that a little bit. We've got to get it, and this is hopefully something you've seen before, but I can imagine like so many different places you can get tripped up in this question if you've not seen them before or not remembered them. So sine hyperbolic u, we talked about the sine squared. Sine hyperbolic squared was cos squared u minus 1. So here we can replace sine hyperbolic u by the square root of cos squared u minus 1. And that is then this. You only have to include the positive value, by the way. This is our principal value. So then we can write it as x squared minus 1. And we've got our result. It's going to be a half, square bracket, then I've got x times the square root of x squared minus 1. Hopefully I've convinced you enough there. The cos u is x. The sine hyperbolic u is the square root of x squared minus 1. Just put them together. And then I'm just changing the order, but then I've got my r cos x here. And then, of course, my plus k. And there we have it. Okay, so remember, if you got stuck with any of those parts along the way, right, we've got our results, and now we're going to be trying to find an area. So figure 1 shows a sketch of the part of the curve C with this equation here. Okay, it's just related somewhat. It's got an arc cos in there. And then the finite region shaded in figure 1 is bounded by the curve C, the x-axis, and the line with equation x equals 3. We're asked to use integration to show that the area of R is given by this. All right, well, let's think about when y is 0. Okay, we need to think about this value here. And we can also see that x has to be greater or equal to 1. Well, our cos of 1 is actually 0 because cos of 0 is 1. So this is going to be our lower limit actually. And therefore, what we want to find is the integral of 4 over 15x cos x between 1 and 3. I'm going to bring the 4 over 15 out, multiply it at the very end. And don't forget, we've got this result. Okay, we're going to be using that at some point. And just keep track of the answer. because we do have these things. As difficult as this question is, we've got some guidance. Okay, well, this is going to be integration by parts. It's got to be. It's a product. It's got an x here, and we've got our cosh x here. Now, normally you would let this equal u. That's the thing. Whenever I'm teaching A-level maths, I'm like, remember late. You always do logs. That will be your substitution first, and then algebra, and then trig is actually after algebra. But the thing is, this is only a little guide. I tell people this, but then if you follow it religiously, you're going to get into trouble here. You actually do not want to be letting this equal u. You can try it, and of course, you may well do that, but then you've got to integrate r cosh x. So instead, which, by the way, is not an easy thing to do. Yeah, and let's not forget, we've got this result here. And we know what happens when we differentiate r cosh x, because we get 1 over. That was in the formula book that I showed you at the start. And then when we integrate x, we're going to get half x squared. So you can sort of see where this is going to come from. This is our way in. So actually, this is going to be u, and this is going to be v dash. I mean, integration is just like, it is incredible. Just a puzzle, isn't it? You just got to try things out, develop understanding. You might go down the wrong path. I got to say, when I did it, I did start by letting u equal x. I was like, yep, I'm just going to follow that normal path. And I was like, how is this going to help with my previous result? And then I switched it around and it all worked out. So u dash is going to be 1 over the square root of x squared minus 1. That's just from the formula book. We don't need to derive it or anything. And v is the integral of x. It's going to be a half x squared. So then remember, we've got, I think this is in the formula book as well, but we've got uv minus the integral of u dash v. That is our integration by parts. So we're going to get 4 over 15. Don't forget about that. And then I put a big bracket there. And we've got u times v, so it will be a half x squared r cosh x evaluated between 1 and 3. Then I am minusing the integral u dash times v. I'm going to be bringing another half out and then writing x squared over square root of x squared minus 1. Okay, amazing. Now I could evaluate this one now, but I don't think I will. What I think I want to do, no, let's just keep going with the whole thing. So 4 over 15 Okay, and now I can sub in. I know that it's going to be minus a half multiplied by this. So actually minus a quarter bracket x squared minus 1 plus r cosh x. And sorry, that is also evaluated between 3 and 1. And don't forget, this is also being multiplied by 4 over 15. So there we go. We can just go straight to that. And now we're ready to sub in values. So I'm going to get 4 over 15 multiplied by, and I'm going to put 3 in. I get 9 over 2 r cosh 3. Then minus a half r cosh 1. Now, if you can spot this, it's going to save you a little bit of time. R cosh 1 is actually 0, because cosh of 0 is 1. We talked about that a little bit before. And then I'm going to minus a quarter, and then 3 root 8 it's going to be when I put 3 in, plus r cosh 3. And then when I put 1 in, this is actually going to give me 0, and so is this one. So actually, just turns out to become that. let's multiply by that 4 over 15. If you do 4 over 15 times 9 over 2, you actually get 6 over 5. So 6 over 5 r cosh 3. And then for the next bit, the 4 and the quarter are going to cancel. So I'm going to get 1/5 root 8. Because it's 3 over 15 times root 8. And then I'm also going to get minus 1 over 15 r cosh 3. Okay, I'm nearly ready to work out r cosh 3. Let's just do 6 divided by 5 minus 1 over 15. This gives 17 over 15 r cosh 3. And you can see in the final answer, they've written 2 root 2. So I'm also going to write it as 2 over 5 root 2, because root 8 is 2 root 2. Now, I'm not going to prove this, but we can use what r cosh x is actually equal to. And I'm going to get 17 over 15 ln 3 plus root 8, or 2 root 2, minus 2 over 5 root 2. Let's factorize out a 1 over 15. Then I'm going to get 17 ln 3 plus 2 root 2. And in the process of factorizing out the 1 over 15, I'm going to need to times this through by 15, and it will give us minus 6 root 2. And we've got there. Oh, so that is how we can find the area of the region under the graph. Awesome. I mean, that is an incredible question. I mean, it looks a lot like a triangle, but it is not. That we have to go through all those steps to get the area. Amazing question. Practice your trig substitutions, your hyperbolic trig substitutions, all these little results that come in. Um, Writing identities down. You might remember your trig identities, then use Osborne's rule to get your hyperbolic identities. This bit here, look for that in the future. You get that in parametric equations and all sorts. Being able to change it to that is really important. Um, Thinking about integration by parts and deciding whether to use what to call u and what to call v dash. Just go with what you think, but don't be afraid to switch it around if it's not quite working out. That's an awkward bit of part B. Yeah, well done with this question.